right, now we're starting section 8, topic 3. Solving equations with radicals and rational exponents, part 1. Solving equations with radicals and rational exponents, part 1. And the target how do you solve a radical equation in one variable question mark and when solving a radical equation why would a solution be extraneous? Oops, sorry. I y'all couldn't see that. Example 1. Directions say solve the following equations. We have 6 times the square root of x minus 4 equals 48. So as you can see, we have a radical in our equation. So these are called radical equations, okay? When you're solving a radical equation, the first thing you want to do is get it isolated. So if there's anything outside of the radical on the same side of the equation as the radical, you want to get rid of it before you do anything else, okay? So this one, you can obviously see that it's not isolated. What's on the outside?
6.
A 6. And since that 6 is right next to the radical, it's being multiplied. The 6 in the radical multiplication. So how am I going to undo that and get rid of that 6? Divide by 6. So 6 square root of x minus 4, that's one term. So I divide that whole term by 6. And I've got to divide every term in the equation by 6. So obviously on the left, the 6 cancels. And I'm left with the square root of x minus 4 equals 8. Now, can I take the square root of x minus 4? No, and that's a binomial. So you're like, well, I can take the square root of 4.
You can't take x.
Right, and so the x minus 4, that goes together. It's not a product. That's not just a bunch of multiplication in there. That's one thing. So if that was x minus 4 raised to the second power, I could take the square root because there'd be 2 identical factors, right? Or x minus 4 raised to the fourth power, I could take the square root of that. But I only have one factor of x minus 4, so I can't take the square root of that.
So can you change it to x minus 4 to the half?
Well, I could, but if what's the opposite? I could just get rid of the radical. I can square it, right? If I take the square root of x minus 4, the opposite of taking the square root is to square it. So just like the opposite, not the opposite's not the right word, the inverse of multiplying here is dividing. If I want to undo, well, the inverse of square rooting is squaring. So what I can do is I can square, but I have to square both sides. I can't just square the left and not the right because that would be changing the meaning of the problem. So what do you think the square root of x minus 4 quantity squared is? X minus 4. What is 8 squared? 64. Now what do? Add 4 to both sides. And x equals 68. Now you want to check these because just like with what we were doing in section 7 with the rational equations, radical equations can have extraneous solutions as well. So you want to check them. Even if you just check in your head, it's important because if you say this is a solution but it's technically extraneous, then you're not going to get it right. So I'm just going to substitute in 68 wherever I see an x above. So that'd be square root of, or 6 times the square root of 68 minus 4 equals 48. So that's 6 times the square root of 64 equals 48. What's the square root of 64? 8 times the 6 that's already on the outside would be 48 equals 48. True story, I'm good to go. Coolio? All right, example 2. We have, open parentheses, 3x minus 5, quantity raised to the 1/4 power equals 20. So you could do really one of two things. If you wanted to convert this to a radical, it would be what? Right, 4th root of 3x minus 5, right? You could do that. And then you could raise both sides to the 4th. Or what I could do is, well, no, don't distribute because that's going to make it, because this is one term. So it's not a product. So I can't do like 3 to the 1/4, x to the 1/4 because I mean product. Yes, it's not a product. It's binomial. Can't do that. So 1/4, if that was an exponent of 1, that would just mean 3x minus 5, right? Well, 1/4 times what would give me 1? 4. This isn't 1/4 times 4, which is technically 4 over 1. 4/4, which is 1, right? So I could erase both sides to the 4th power, and that would make that exponent go away. All right, so opposite of raising something to the 1/4 is raising it to the 4th, or the reciprocal, multiply by the reciprocal. So 3x minus 5, quantity raised to the 1/4, and I'm going to raise that to the 4th power. But of course, I can't just raise one side to the 4th power. I would have to raise both sides to the 4th power. So what do you think 3x minus 5 quantity raised to the 1/4 quantity raised to the 4th is? 3x minus 5. Now 20 raised to the 4th means 20 times 20 times 20 times 20. So 20 raised to the 4th power, 160,000. Now a lot of students will go, okay, something's not right because I think my number's too big. It's not. You can get big numbers. All right, so now this is a way easier equation. What should we do next? Add 5. So we have 3x equals 160,005. Then we can divide by 3. And x equals, I don't know if that divides evenly.
It
Does?
does.
Sweet. So 53,335. And of course we should check ourselves before we wreck ourselves. So that would be 3 times 53,335 minus 5 raised to the 1/4 equals 20. So that's 160,005 minus 5 raised to the 1/4 equals 20. So obviously that's 160,000 raised to the 1/4 equals 20. Now 160,000 raised to the 1/4 is the same as the what in radical form? The 4th root, right? So I can do that in my calculator. I would do 160,000 second power, and I get 20. Does 20 equal 20?
Yes.
Yes. Anybody have a question on that? Now, these kinds of problems, obviously, if you're doing well on the PERT, I hope you would probably start seeing problems with radicals in them. So knowing how to convert from radical to a rational exponent and vice versa, imperative in order to solve these. You may have a question? All right, example 3. If you have friends in class that aren't here today, let them know that I actually did record this lesson, which I haven't been doing lately. But this one is recorded, so make sure they watch it and get the notes, because as you can see, it's probably maybe a little confusing just to look at it on paper and not hear the explanation of it. All right, we have 5 times the square root of x plus 13. And then you have a minus 4 that is not under the radical equals 46. A lot of times with these you make mistakes. I make mistakes just by your handwriting, making your radical sign look too long and thinking something is under the radical that's not actually under the radical. So I try to make it obvious when something is not under the radical, because that's going to change the problem. So like I said before, if you have a radical in an equation that you want to solve, you must isolate the radical before trying to square both sides or anything like that. Get it by itself before you do anything else. So in this example, what would I do first, do you think? Exactly. Add 4 to both sides. So I have 5 times the square root of x plus 13 equals 50. Is my radical isolated? Not yet. Divide by 5. So obviously, see my 5's cancel. And I have the square root of x plus 13 equals 10. So could I just subtract 13 from both sides? No. What do you say I'm supposed to do? Square it. Because x plus 13 is being square rooted, right? So if I want to get rid of that radical, the opposite or the inverse of square rooting something is to square it. So I'm going to square both sides. And in my notes, I like to rewrite the problem so you can see from one step to the other how it changed. Obviously, if I were doing my own homework, I probably wouldn't do that, but so what's the square root of x plus 13 quantity squared? X plus 13 equals, what's 10 squared? 100. Now what? subtract 13. And x equals 87. Let me just check it real quick. So that would be 5 times the square root of 87 plus 13 minus 4 equals 46. What is 87 plus 13? So 5 times the square root of 100 minus 4 equals 46. So square root of 100. 10 times the 5 that's already outside. So 50 minus 4 equals 46. Is this a true statement? Yes. Right. Example 4. I have 3 more examples. This next one will go quick. Example 4. Open parentheses. 2x minus 3 quantity raised to the 1/2 equals 17.
Square both sides?
Square both sides. If you could rewrite it as a radical, it'd be the square root of 2x minus 3, and then you would end up squaring it, right? So instead of doing that, you could just square it from now. So same thing as multiplying by the, not multiplying by the reciprocal, but raising both sides to the reciprocal 1/2. So 2x minus 3 raised to the 1/2 equals 17. And if I want to get rid of that, I will square both sides. 1/2 times 2 is just 1. So technically that's 2x minus 3 raised to the first power, which is just 2x minus 3. And 17 squared is 289. Easy. What do we do? Add 3. So 2x equals 292. Divide by 2. And x equals 146. Let me just check myself real quick. So that's 2 times 146 minus 3, quantity raised to the 1/2 equals 17. 2 times 146 is 292, right? Right. So that's 292 minus 3, quantity raised to the 1/2 equals 17. 292 minus 3 is 289 raised to the 1/2. And 289 raised to the 1/2 means what? Square root of 289. So 289 square root is 17. True statement. You may have a question? Okay. Example 5. We have the square root of 4 minus x equals x minus 2. All right, so we have a radical equation. Our first thing is we isolate the radical. So in this case, it's already isolated, right? So we can go ahead and get rid of the radical. How are we going to do that? Square both sides. Now on the right side, you have 2 terms. You don't want to just do x squared and negative 2 squared. You're going to square the whole thing together. So it's going to be x minus 2 quantity squared. All right. What's square root of 4 minus x quantity squared? 4 minus x, right? Now, x minus 2 quantity squared, is that x squared and negative 2 squared? No, it's x minus 2 times x minus 2. What do you think we do now? Distribute, right? We know how to do that. So we would have 4 minus x equals x squared minus 2x minus 2x plus 4. Okay, so this is kind of like what we did in section 7. We have quadratic terms and linear terms. If we're trying to solve for x, in this case, can we isolate the x, or are we going to need to get it set equal to 0 and in standard form?
Probably
Set equal to 0, okay? So, but let me simplify my right side first, because I have like terms. So that's x squared minus 4x plus 4. And then I will move everything, in this case I'm going to move it over to the right. So I'm going to add x to both sides, and I'm going to subtract 4 from both sides. So I have 0 equals x squared minus 3x, and 4 minus 4 is 0. So how are we going to solve this?
You take out an x.
Right, I have a GCF of x, right? If I take it out, what's left? X minus 3. Can I factor x minus 3 any further? No. Am I ready for my solutions? What are they? 0 and 3. X equals 0. And if I set x minus 3 equal to 0, I would get x equals 3. So I'm going to have to check both of these solutions. So I'm going to check x equals 0 first. So it's a square root of 4 minus 0 equals 0 minus 2. So 4 minus 0 is 4. What's the square root of 4? 2 equals negative 2. Is that true? No. Now I know that the square root of 4 can be a positive 2 or a negative 2, but when you're checking radical equations, you only take the positive square root, okay? 2 does not equal negative 2, so 0 is what?
Not extreme.
It's extraneous. So let me check x equals 3. So that'd be the square root of 4 minus 3 equals 3 minus 2. So 4 minus 3 is 1. What's the square root of 1? 1 equals 3 minus 2 is 1. That's a true statement. So x equals 3 is my only solution. So we've done a lot of work today. But I have one more. Sorry. Anybody have a question? All right. Aren't y'all glad you came to school today? To make this up. If you didn't. Example 6. We have x minus the square root of x minus 2 equals 4. Is my radical isolated? No. What do you think I do first? Is this x being multiplied by the square root of x minus 2? No. Is the x being subtracted?
Yeah.
The x is positive. Yes, sir.
Will we add the square root to the sides?
You could do that and then subtract the 4. You could totally do that. I would probably, this is what I would do. But you can do that, and it's just fine. We'll have the same thing. So I would subtract the x. but my radical's still negative. So that's negative square root of x minus 2 equals 4 minus x. Is my radical isolated? No. Technically, isn't that a negative 1 out there? That's being multiplied by x minus 2. So how could I undo that? Divide by negative 1. And I'm dividing this whole side by negative 1, both terms, okay? So the negative divided by negative is a positive, so that gives me the positive square root of x minus 2 equals 4 divided by negative 1 is negative 4. Negative x divided by negative 1 is positive x.
And now square both sides.
Square both sides. And really, I'm probably going to rewrite this and rewrite it as x minus 4, just so it doesn't look weird, you know. So yes, now I'm going to square both sides. So square root of x minus 2 quantity squared is
X minus 2.
x minus 2 equals x minus 4 quantity squared. Is that x squared and negative 4 squared? No. It's x minus 4 times x minus 4. Right? Perfect square trinomial. So if I distribute that, I get x squared minus 4x plus 16, which remember we learned in identity, we already knew that that was going to be x squared minus 8x plus 16, but if you forget it, just distribute it out like I just did. So to solve for x, I've got quadratic terms and linear terms, of course constants, but that doesn't really affect my decision. Can I isolate the x, or do I need to get it set equal to 0? Equal to 0. And since my quadratic's on the right and it's positive, I'm going to move everything over to the right. So 0 equals x squared minus 9x plus 18. Does that have a greatest common factor? Nope. How can I solve a quadratic? Factoring or quadratic formula or completing the square. But I think this is, if I prefer factoring, if it's factorable, that's what I prefer. And then if it's not, then I prefer quadratic formula. But I just keep saying that because I want you to remember you have all those options, right? So to factor this, we know A is 1, B is negative 9, C is 18. So we need two numbers that multiply together to give you AC, which is positive 18, and then add together to give you B, which is negative 9. Negative 6 times negative 3 is positive 18, and negative 6 plus negative 3 is negative 9. So that's perfect. 0 equals x minus 6 times x minus 3. And would we divide and slide? No. So now it's time for my solutions, finally. So x minus 6 equals 0. What would x equal? 6. X minus 3 equals 0. What would x equal? 3. I think it's especially important. You should always check your work, of course. But I think it's especially important to check when you get two answers with radical equations, because a lot of times one of them is going to be extraneous. Okay, so if you're not going to check every problem, at least check it when you have two answers. All right, so I'm going to check those over here. I'll check 6 first. So I'm looking up at my original, so that's going to be 6 minus the square root of 6 minus 2 equals 4. You could also come down to the part where your radical is already isolated and you can check it from there. Sometimes that's easier. Well, it usually is easier. So that's 6 minus the square root of 6 minus 2 is 4. What's the square root of 4?
2.
Does 6 minus 2 equal 4?
Yes.
Okay, so 6 is a solution. That works. It's not extraneous. Let's check 3. So that would be 3 minus the square root of 3 minus 2 equals 4. So 3 minus, we know 3 minus 2 is 1. What's the square root of 1? 1. What's 3 minus 1? Does 2 equal 4? No. So 3 is extraneous. Not a solution. So hopefully you can write the summary somewhere on your notes. Anyone have questions before I pause this video and give you your assignment? Okay.